Hello everyone, welcome back to my YouTube channel on Civil Brains. So right now we are into the lecture 6 on the series of one-way slab. So in this lecture we'll see how a curing is to be done. Of course, before doing the curing we need to do the de-shuttering of a slab, and then we'll try to understand like why curing is important and how it has to be done, right? So right now this was a slab, we had done the concreting, you can see it, and now just I'll play the video here. You can get overall view of that particular building, right? So this was the slab which was in the second floor, and all the concreting work has been done. So once the concreting work has been done, next is what we are supposed to do. We need to take out the beam outer side. You can see a small, you can see it here, the beam outside shuttering has been taken out. I mean de-shuttering is done, and immediately you have to start with the curing work. Okay, either you can do the curing work and then start doing the de-shuttering. There is no such rules, but curing has to happen as soon as possible so that we can avoid the cracks, right? Yeah, so I hope this entire building you're familiar with. Now we'll try to see how the curing has been done for this. So you can see here, right? Yeah, you can see it here, all the outside shuttering, whatever boards you had put, no, you can see it here also. All those things has been removed now, and of course it has been spread with the water. I mean the sprinkling of water has happened, but this is not the right way of doing, because since it is a slab, no, slab is a horizontal element. Now of course since it's a very next day itself, you just sprinkle the water here. Otherwise the best option to do the curing for the slab is you have to create a bunch, and then you have to allow the water to stay there. So let me give you an idea regarding that. So see, all these things I've covered in my course, like what is curing, then I've explained this with in a more funnier way, right? What exactly is curing, why we have to do the curing and all. So those things you'll get either in my concrete technology course or in the site engineering course. Okay, the process of spraying or sprinkling the water artificially over the surface of a concrete to keep it moist is called as curing of concrete. The functions of curing are to supplement the loss of water in the concrete from the evaporation, and to supplement the water consumed in the hydration of the cement, right? So water is actually not required for the strength gain, because whatever water is there in the concrete, right, I want to save that water. Due to the evaporation, what will happen, the water which is inside the concrete, that will get evaporated. So I want to stop that evaporation. So what I'll do, artificially I'll provide the water over the concrete surface. So even due to the sunlight, right, so even the water gets evaporated, the water which you have provided artificially, that will get evaporated, and not the one which is inside the concrete, right? If the water inside the concrete gets evaporated, what is going to happen? The hydration of the cement is not going to happen. If hydration of the cement will not happen, whatever strength we were supposed to achieve, that will not be achieved, right? And also during the concrete technology course, we have understood that something called box compound. What are those box compound? Tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminate ferrate. All these are your box compound. And especially if you remember the C3S, tricalcium silicate and dicalcium silicate, these are the two people, okay, two compounds which are actually responsible for the strength gain. Of course C3S will give you fast strength gain, whereas C2S is responsible for the ultimate strength of the concrete. In the initial phases, in the first 7 days, whatever strength you are going to get, no, that is due to the C3S, of course, right? And also because of these two compound, you get a gel, right? If you have seen concrete technology course of mine, in that I have explained, you get a gel called CSH gel. So this gel is called as tobermolite gel, and this itself is that gel which will help in the binding of a cement. Hence we call cement as a binder. Of course all these things are the chemistry point of view, how you understand the cement and all. So this CSH gel is responsible for the formation of that binding property, and this CSH gel will form when the C3S will react with water and all. And if that water itself is not there, there is no production of CSH gel, which in turn means that there is no binding agent, and if there is no binding agent, of course there is no strength gain. So that is why curing has to be done, right? Yeah. So now we'll go back to that. Yeah, right. So this is what I was speaking of, curing of concrete. Along with that, see, you can see it here, this is the best way of doing the curing for the slab. So in this way you have to create a small bunds, and then allow the water to stay here. So what will happen, the water is going to stay here for a very long period of time, so that a good amount, so that the curing is going to happen. Then you can even put the gunny bag also, that also can be done. It's all left to you how you want to do it. So to give you a better way, so all these things I've explained in my course, I'll not explain it here what exactly is the meaning of this. To put it in a better way, you see these are the different ways of doing a curing. You have water curing, we have membrane curing, we have application of heat, that is through application of the heat how you can do the curing, that is like steam curing, infrared curing, electrical curing. So under the water curing we have direct application and we have wet covering, and under the direct application we have immersion, ponding and spraying. So what is this ponding, what is this immersion? So immersion, if you understand, during our college time we used to do the cube casting, right? And once the cube casting was done, we used to keep it inside the water, right? So that is called as immersion curing. Okay, and then we have this electrical curing and all, but practically this is not applicable in India. It's quite expensive, electrical curing and all. The best curing what you can do is of course the water curing. So in this way you make use of the gunny bags and you do the curing. Depends on what element you are doing. If it is a slab, then you have to do ponding. It's very difficult for you to wrap the slab with this gunny bag and do the curing. For horizontal elements, you can either do a ponding or you can put a gunny bag, something like this. For vertical elements like the column, you cannot do that ponding. You have to wrap the column with a gunny bag and then you do the curing. So again, other than that, we have different types of curing. You can see it here: immersion, ponding and sprinkling or spraying of water. So if you do a plastering and all, we do the sprinkling or spraying of water. So what exactly is this ponding? I'll show it here. You can see it here, no? So these are called as ponding. So this is ponding. If you remember in a college time, we used to do the cube casting, then cylinder and the beam, right? Then we used to immerse that in the water tank. So that is called as immersion. And also you can see these are the pre-stressed concrete, the sleepers and all what you get in the railway track. So this is how the curing is done. So all those things I've explained in my concrete technology course, the site engineering course. You can learn all those stuff from there in a very structured manner. Anyhow, we'll go back to the video again. So you can see the sides, right? All the sides, whatever this you are done, shuttering you are done, everything they have removed it here. Only the sides we are going to remove. We are not going to remove the bottoms and all. So why we shouldn't remove the bottoms, I'll explain you why the bottoms should not be removed immediately. There's certain clause according to IS 456-2000. We need to follow that. And these are the double bars which will go to the next flight, just in case if you have a plan of putting a staircase. Okay, so these are the sides what we had. Everything has been removed. You can see it here, no? You see it here. This is that slab thickness what we wanted to maintain of 150 mm, and this 150 mm is maintained here. Okay, this 150 is maintained here. So finally, even for the staircase also they have done the curing. Okay, on staircase you can put those gunny bags so that the water is going to stay. Here you cannot do the ponding, right? It's better you put the gunny bag over that and then allow the water to stay on that, so it will absorb the water, the gunny bag, and that's how the curing will happen. Yeah, now we'll go to the most interesting part. So the most interesting part is about the de-shuttering time, when it has to be done exactly. So if I take it to IS 456 2000 code book, and if I go to the clause number 11.3.1, which says that type of the formwork and minimum period before striking the formwork. So if it is a vertical formwork to the columns, walls and beams, that means if you're putting up the column shuttering and all, so it's a vertical element, right? It's written here vertical formwork. Formwork can be anything. Formwork can be a wooden formwork. Formwork can be in terms of steel. It can be anything, doka formwork, whatever it may be, to the column. And so you can remove with it 24 hours, that's 16 to 24 hours. So most of the time we wait till 24 hours. Okay, so that is why you can see the sides have been removed, because it has been 24 hours, even less than 24 hours, because we done the casting of this staircase around 5 o'clock in the evening, but early morning by 10:30 we have done the de-shuttering of this, right? Since it's a vertical element, so it's okay. It's mentioned here 16 to 24 hours, and that is okay. But again, you need to understand this. Okay, whatever they have mentioned it here, no, this is applicable only for below 15 degrees Celsius. That means up to 15 degrees Celsius, if your temperature is there, then you can follow it here. It's written here, while the above criteria of the strength can be guiding factor for the removal of the formwork in a normal circumstances where the ambient temperature does not fall, it's written does not fall below 15 degrees Celsius, and where ordinary Portland cement is used and adequate curing is done, the following striking period may deem to satisfy the guideline. That means if your temperature is 15 degrees Celsius, more than 15 degrees Celsius, then this is the right way of practicing. Just in case if you're doing the concreting and all in a very cold climatic region, in that case you just have to wait for some more time. And also there may be some other test, I don't know exactly, but we have understood a concept of maturity of a concrete, right? If you had taken my concrete technology course, or if you had understood the maturity concept of a concrete, so that is how we come to know whether my concrete is matured or not. We had done certain equations, we had solved certain numericals on that during our engineering days, so maybe those concepts can be applied then. Otherwise in the 90% of the cases, at least in India, unless it is on the northern part like Himachal and all, but other than in the southern part and all, it's the temperature is more than 20 degrees Celsius. So in that case you can usually follow this criteria. So it's written vertical formwork to columns, walls and beams. Yeah, so this is how you have to apply it. Again, all these things like what is this 3 days, 7 days, 7 days, 14 days, all these things is covered in my site engineering course, where I explained you exactly how to remove the bottom and all. Anyhow, you see it here. So if I go back, so you can see this, no? So this is a beam here, right? So under the beam, if I again go back to beginning of the video, yeah, see here now. So all this this is my cantilever slab, isn't it? Now what is this? This is a centering work what I have done. So immediately next day I cannot remove these props. These are called as wooden bellies, or you can make use of MS pipes here, MS props. So this you cannot remove immediately on the next day, because since it's a slab and all, and of course it's a cantilever slab, it will not have the strength itself on the next day itself, isn't it? It's something like a newborn baby. Is it possible for a newborn baby on the very next day to stand up and crawl? Stand up and run? It's not difficult. I mean, it's very difficult, right? Of course it's impossible. In the same way, this concrete is like a newborn baby now. So if the moment you remove these props and all, it's going to fall. It doesn't have even a strength to carry its own weight now, right? So that is why the code says that you have to wait for all these days. You have to wait for 7 days, you have to wait for 7 days and all. So it's written soffit formwork to the slab, that is props to be refixed immediately after removal of the formwork. It means that even though if you want to remove it, no, you need to remove these props, take out the slab centering and then refix the props. So the what we usually practice is that we don't do all these things. We wait for at least 14 days. If it's a very big slab, we wait for 21 days, and after 21 days we'll try to remove the props and the slab centering and everything, the beam bottoms and all. Only the sides you can see these sides, no, the sides we have removed because it's a vertical element and here no load is coming on the side. So that is why we do the de-shuttering of the sides on the very next day, whereas the slab centering, the vertical and all, nothing will be done. We either wait for 14 days or 21 days and then we take it out, we strike out everything. Okay, that is how you have to understand all these things. It's covered in my course how to do all those things. Yeah. So this is how the course is made up of. I've explained all those things. De-shuttering of a footing very next day. So what is the importance of this curing? Okay, it's like a newborn baby. Immediately it cannot, take its own weight. It will take some time and then it's going to carry its own weight, right? So in this way it is explained in my course. And also it depends on the age of concrete. Like see, on the very 7th day your concrete is going to gain 67% of the strength. So that is why you can see it here, no? See, on the at the end of 77 days the strength gain is 67%. After 14 days it is 86%. 28 days it's 1.0. It means 100% of the strength gain will happen. Even after that 3 months, 6 months, 1 year, concrete is going to gain the strength. But the first 7 days you can see the variation in the strength is almost 67% of the strength will be gained. So that is why the initial 7 to 10 days for the concrete is very important. That is why we need to do the curing regularly, and we should not allow the evaporation of the water in the first 7 to 10 days. So the first 10 days curing is very important. It's like a concrete which is kept in ICU. You take good care of it, only then the strength gain what you were supposed to gain, like let us say M20 grade of concrete or M25 grade of concrete, so that will be practically achieved. If you don't do the curing in the first 7 to 10 days in a proper way, like let us say today you did a curing, after 3 days again if you do the curing, then this whatever we are getting 67% of the strength, that will not be achieved, and maybe that may lead to certain problems in the structure later. So that is why we have to do the curing in the right way, and at least 7 to 10 days we have to follow, we have to do proper curing of a concrete for the concrete work, right? All those things is covered in my course. You can buy and learn from there, but anyhow I've given you a small idea what exactly you're going to learn and in which level you're going to learn all these things. Yeah, so for someone who is new to my channel, see all these courses are available on the Udemy platform. So the price will be 700, sometimes it will be 1600, but if you ask me for the coupon, I'll be providing you the coupon. Otherwise you can download my Civil Brains app, so there you're going to get all these courses for 400. The first site engineering course what I have is around 24 hours, which is a bestseller on the Udemy, which has got 4.4 star rating. Then the next is you can learn quantity estimation, survey, building estimation, bar bending schedule and all. So it has almost 21 hours of the content, 162 lectures, 4.6 star is a rating on the Udemy, and this is a bestseller. Then if you're finding it very difficult to understand the structural drawings and all, so I have a course around 29 hours which has 4.2 star rating on the Udemy. You can buy this course. Then I have prepared a one course on 45 days internship on building construction practices on the site. So it's a mix of all my 7 courses where you are going to learn a bit of site engineering, quantity estimation, drawing, reading, ETABS, basic project planning and all, which has got around 46 total hours, 197 lectures, which has got even 4.4 star rating. There's a course on Diploma in Basics of Civil Engineering, which has got 3.9 star rating, having 19 total hours. There's a course on concrete technology, which I was explaining here, which has got 4.8 star rating. It's a bestseller on the Udemy. And then of course there's a ETAB course here, which is having 4.1 star rating, 21 hours of the total content, right? And of course there's a basic project planning course. So if you're interested, you can buy the course. I would always suggest you to start with the site engineering course, followed by the quantity estimation, followed by the drawing reading. If you want to buy all the 3 courses, you'll be getting it in a combo of 1000 rupees. Instead of paying each course 700 or 400, you can get it for 1000 or 1200. 100 or 200 rupees variation will be there in the price of the course, depends on the offer. If you want to buy all the 7 courses of mine, it will cost you 2500 rupees. You will get 640 pre-recorded videos, 130 hours of the content, and that will make you a very good site engineer, or it will make you a very good structural engineer and all, right? So I hope you have enjoyed the lecture up to here. So we'll see you back in the next lecture. Thank you. And also in the next lecture I'll upload a video of entire this coastal region of Murdeshwar, so that will come to know how exactly the place looks. So please do subscribe to this channel and share the videos, so that others also get benefited from the channel. So we'll see you back in the next lecture. Thank you.